In this video, we're going to highlight the basic starter schematic, the way we learned how to do in the intermediate course. We're going to use orange for everywhere that we expect to measure 12 volts. We're going to use green for the load when the load is active, and we're going to use yellow as our ground path. And in this basic starter schematic, we have three loads. We have the hold-in coil over here on the left, this center coil, which is the pull-in coil, and then we have the motor itself, which is a load. So when we turn the key to the start position, we would actually have orange all the way down until the top of this coil. The coil itself would be the load, which would be green, and then yellow would be the rest of this path going down to ground. With the pull-in coil, the highlighting would look different after this switch closes over and the 12 volts gets applied from the battery to this M terminal. So first we'll look at it when we energize the coil by just turning to the start position. We would have 12 volts or orange all the way down to here. We would have green being the load for this coil and green being the load, which is the motor. A split second later, when the switch gets closed, then the orange or 12 volts that we have coming all the way down through here would now still power up the load, which is the motor, but it would not power up the pull-in coil because I would have 12 volts on this side and 12 volts on that side. So essentially this load would be inactive, but since there's a ground path here for the motor, my motor would now spin. Now you might ask, why wouldn't the motor spin when I just energize the pull-in coil? Because I have the pull-in coil and the motor in series, and shouldn't I have the motor spinning just from that circuit? And the answer is, because these two components are in series when we're first turning to the start position, and the resistance of this coil is many, many times more resistance than the winding in the starter motor, what's going to happen is the way that the two loads in series are going to share the voltage is going to be proportional to what their resistance is. And since this coil is much higher resistance, many, many more times higher, it's going to use up most of that 12 volts. And even though there might be a small voltage drop across the motor from this initial circuit when we turn on the pull-in coil, it's not enough for it to power up the motor. And then once the switch pulls over and we have direct power 12 volts going to the motor, now the motor gets the full 12, it's able to activate. In the next video, we're going to start talking about the diagnosis of why the starter won't work and discussing what you might hear when you're going to start the car if some of these conditions were present.